What you're looking at right now looks like a wall of random text. It's thousands of lines of the letters A, C, G, and T repeated over and over again. But this isn't random. It isn't just ink on a page. These pieces of paper actually represent my profile picture. I've been obsessed with data lately, specifically how we can shape it, hide it, and move it around to produce something new. On this channel, we've hidden secrets inside images using pixels, and we've buried text files inside audio waves. But recently, I started wondering about the ultimate storage device. I'm not talking about hard drives or SSDs. I'm talking about human DNA. Nature doesn't use zeros and ones. It uses a biological language made of 4 chemical bases: adenine, cytosine, guanine, and thymine. And that got me thinking, if computers run on binary, which is base 2, and life runs on DNA, base 4, there has to be a mathematical bridge between them. If I could build that bridge, I could theoretically take any file from my computer and translate it into a form of DNA-based data. So I decided to try it. I wanted to take my digital profile picture, which is just a block of raw binary data, and convert it into a genetic sequence. I wanted to see if I could turn my digital identity into a physical object, like this document over here. But as I quickly found out, trying to force computer code into a biological format isn't as straightforward as it seems. The logic behind this is surprisingly elegant. Computers store data as binary, zeros and ones. DNA stores data as base 4. Since 4 is 2 squared, we can map every possible pair of binary bits to a single DNA letter. We can say that 00 equals A, 01 equals C, 10 equals G, and 11 equals T. This simple key allows us to take any file on a computer, an image, a song, or a text file, and translate it directly into a genetic sequence. To make this happen, I wrote a Python script that opens my profile image, reads it byte by byte, and performs this translation. It then formats the output into a massive PDF document. I programmed the script to add a header to every page that read confidential DNA sequence data to make it look official, just playing around, along with the page numbers at the bottom. This script generated a couple of pages of genetic code, looking exactly like a real genome sequence, and this is what I came up with. This wasn't just code on a screen anymore, it was a physical object, sort of. But I couldn't just leave it there. To prove this wasn't just gibberish, I needed to verify it. I needed to prove that I could turn this text back into an image. So I wrote a second program to read the text from the PDF and reverse the math. And that is where I hit a wall. The restored image wasn't an image at all. It was completely corrupted, just digital static and noise. Windows couldn't even open the file. I stared at the code for hours, trying to figure out where the math had failed. The conversion logic was correct, the file reading was correct, so why was the output destroyed? I realized I had created a massive logical error. The problem wasn't the DNA. The problem was the confidential header I was so proud of. My decoder script was too obedient. It scanned the pages looking for text and it found it. It saw the letter A inside the word data in the header, A and the G inside the word page in the footer. So the script didn't know these were English words. It treated them as genetic code and injected them into the data stream. In the world of binary, positioning is everything. If you insert even one extra letter at the start of a sequence, every single bit after it shifts to the right. This is called bit shift, and it scrambles the entire file structure. It injected garbage data that misaligned the entire image, turning my face into static. Now to fix this, I had to change how the computer looked at the file. I had to implement a purity filter. I rewrote the decoder with a much stricter rule. Instead of just grabbing text, I told the computer, read every line, but if you see a number, a space, or any letter that is not A, C, G, or T, throw the whole line away. This acted like a digital enzyme. It looked at the headers, saw the letter D in data or the number 1 in page 1, realized they were contaminants, and deleted those lines entirely. It ignored the human text and extracted only the pure genetic sequence. I ran the script again, the progress bar filled up, and this time it worked. My profile picture was pulled back out of the text file, pixel for pixel, exactly as it went in. We successfully turned our digital image into a biological format. I printed it out onto a physical paper and then digitized it back into an image without losing a single bit of information. This project was just a fun experiment to see if I could make data tangible. I have a much bigger, more complex project involving this DNA process coming in the near future, so make sure you're subscribed so you don't miss it, and thanks for watching. See you in the next one.